Welcome to EDU World Space.
Alright, so here is the problem 23.36. In this question, we're going to write the formula for each of the following compounds. So question A, we have tetra aqua dibromo manganese 3 perchlorate. Alright, so first we find the center metal, manganese, we have Mn, and the number 3 in Roman means that the oxidation state of the center metal is 3+. And then tetra aqua means 4 water ligands. Dibromo means 2 bromide ligand. Then perchlorate is ClO3-. Alright, so then we have the complex formula as manganese with 4 water, 2 bromide, bracket. So the total oxidation state of this part will be 3. This is 0. This is -1 times 2. So total is 3 minus 2 equal to +1. And perchlorate is -1. So the ratio will be 1:1. And that will give us the formula of the compound. Now let's look at question B. We have bis bipyridyl cadmium 2 chloride. Alright, so for this complex, we have the central metal atom cadmium right here, and it has an oxidation state of 2. And bipyridine is a neutral ligand, and bis means 2. So there are 2 ligands of bipyridyl, and chloride is Cl-. So if we put this together, we have the complex formula cadmium bipyridine 2 bracket. So this oxidation number of this part will be 2+, and this is 0, so it will be 2+. So in order to balance with chloride, which is -1, we will need 2 of the chloride. So that is -1 times 2. So the oxidation number of the complex should be 0 or neutral. So there should be 2 chloride ions to balance for the complex. Now question 3, part C, we have the complex potassium tetrabromo orthophenanthroline cobaltate 3. Alright, so in this complex, we find the central metal is cobalt, CO, and it has an oxidation number of 3, so it has 3+ charge. And from the name of the compound, we find each type of ligands. Tetrabromo means 4 bromide ligands. Orthophenanthroline is just 1 O-phen ligand. And this is a neutral ligand. So the formula of the compound will be, so potassium right here, And inside the bracket, we have cobalt O, Fin, and 4 bromide. So the total oxidation state for this part will be 3 plus 0 minus 4. That will give us -1. And potassium ion, we know that it has a positive 1 charge. So 1 to 1 will be the ratio. So this is the complex formula for part C. All right, so now let's look at question D. We have cesium, diamine, tetra, cyanochromate 3. All right, so in this complex, the chromium, right here, chromate, Cr is the central metal atom, and it has a oxidation state of 3+. And each type of ligands are the diamine, which means 2NH3, tetracyanide means 4Cn-, and cesium is Cs. Alright, so now we balance out this two. First we write cesium right here. And inside the bracket we have center atom Cr with NH3 and 4 cyanide. So the oxidation state for this part will be 3+, NH3 is 0, cyanide is 4, so it's 4, 3 plus 0 minus 4 equal to -1. And we know the oxidation state for cesium is +1. So the ratio between cesium and the complex is 1 to 1. So the formula will be this for part D. All right, now let's look at part E. We have the compound tris, ethylene diamine, rhodium 3, tris oxalate cobaltate 3. Alright, so in this complex, the cation representing this complex is this part. This is the entire cation. And this cation represents, and in this cation, the central metal is rhodium with +3, RH +3, and tris indicate that it has 3 ethylene diamine. And in this molecular formula, ethylene diamine can be represented as En. And the formula for the cation will be rhodium En3. And since the ethylene diamine has 0 oxidation number, so this entire part will be 3+. So this is the cation part. Now let's look at the anion part. Represent is tris oxalate cobaltate 3. So in this anion, the center metal ion is cobalt, Co, and it has an oxidation state of 3+. And the oxalate, tris oxalate means there are 3 oxalate ligands, and oxalate are written as C2O4 2 minus. So the formula for the anion will be CO C2O4 3, and this will be 3 minus. So as both cation and anion have the equal charge, positive 3 and negative 3, so the formula of the compounds will be simply 1 to 1. So we will just write rhodium En3 cobalt C2O4 3. So that will be the neutral compound for question E. And remember, this is the cation part, and the color in green is the anion part.